Respected chairman of this session, Dr. Ravichandran, um, um, and officials from the Forest Department, Dr. Naveen Kumar, at the first stage. And first of all, I would like to um, thank the organizers of this mega event, Government of India, as well as our local organizers, Dr. Sivaburman and Dr. Mohan Raju, for giving me an opportunity to talk in this forum. So, since this is after lunch session, I hope you will listen without any disturbance that naturally happens. So let me continue. This NIOT started in the year 1993 at IIT Madras, Indian Institute of Technology, Madras, in a department, Ocean Development Department. During that, our Department of Ocean Development, that is presently called Ministry of Earth Sciences, given many projects to the department. There it is culminated to develop this NIOT. Then later, around 95, they occupied a place in ICL, the SR building at IIT campus itself. Then they got land, separate land at Pallikarni, and developed a big campus. And in that, during that time, we previously this NIOT was started as engineering institution. Even now, with, for developing various kind of technologies, that is for supporting ocean, that is researchers, as well as to develop technology to transfer or cater the need of various people. So in that way, it started. So during that time, during 98, there was a project on lobster culture that was given to NIOT. So that time, living marine resource enhancement, like that, a project was started, and it was given to NIOT, and we happened to be the biologist started entering into the NIOT, and we started this group. From there onwards, we started many other programs, and we involved in various research work related to biotechnology. Now our group is called Ocean Science and Technology for Islands. In that, we mainly concentrate on marine biotechnology. Our strength, we have strength of our engineering support from our engineers, or marine engineers. So we have the technology for biotechnology, as well as the support from that. We could establish a lot of ocean-related activities. So that's how it started. So as I said, this one, our NIOT is under the Ministry of Earth Sciences, and it is particularly to develop technology to solve various engineering problems associated with living and non-living resources of Indian exclusive economic zone. And into that, various categories of our objectives are there. So in this NIOT, these are all the programs being operated. That is core technology programs, which you see groups including coastal processing and modeling, hydrographic and geographical surveys, offshore structure, mechanical design, then assembly and integration, quality assurance, offshore handling, marine sensors and electronics, instrumentation. And in that, one of the group is Ocean Science and Technology for Islands. That is the group we are working. In that, this center was established during the year 1999 as Andaman Nicobar Center for Ocean Science and Technology as ANCAST. Right now, it was during 2018, it was renamed as Atal Center for Ocean Science and Technology for Islands. And there are other groups like various programs like submersible, deep sea submersible, deep sea mining and desalination, gas hydrates. And we have a group called that is underwater vehicle, autonomous underwater vehicle. Through that, ROVs and many other instruments are being developed, ocean research instruments. Then we have vessel management cells also. In that we have 4 ships, ocean-going ships. 2 are coastal research vessels, and another 2 are ocean-going vessels, which can go up to one of the vessels, Nidhi, which can go for that Antarctic cruises also. Then we have ocean observation system, through which only we are deploying data, that is data-wise all over Indian western east coast as well as offshore areas. Through that, we are collecting a lot of atmospheric and ocean data and transferring this to NIOT, INCAI, and this data is being used for weather prediction by IMDs. So this is the program. So in this, we are going to talk only about our activities related to islands. That is particularly in that local institution. That is, of course, what we are doing. So here our major programs are open sea cage culture of fishes, marine algal biotechnology, marine microbial biotechnology, island resources information system, then seawater quality monitoring. Then we are doing consultancy project like environmental impact assessment studies, air quality monitoring, as well as we provide a lot of supporting for our engineering group. And they have demonstrated here underwater the current turbines, and they have deployed many other equipments in Andaman Nicobar Islands for testing. And those kind of during those times, we have our engineering group comes here and they do all the work. Further, we do a lot of supporting. And coming to the first one, open sea cage culture. In that, this Andaman Nicobar being a remote place, and naturally it has lot of creeks and bays, and people think that we can do a lot of fishing activities as well as we can promote fish culture, so that we try to test whether this is possible in a very higher way or something like that, or whether we can do it in every place or promote this thing. For that purpose, we have designed the cages, these open sea cages. Normally, these cages are 9-meter dia, and the depth is also 9 meter. So it is a total cubic meter of 320 cubic meter. So, so in this marine aquaculture related fields, we have worked in various programs like farming and patterning of spiny lobsters, mud crab patterning, then deployment of fish aggregating device, and this artificial reef also we work, and also open sea cages. So we can see that this objective of this fish cage culture is developing a cage suitable for local environmental conditions. So different cages of a diameter 9 meters, 12 meters, 20 meters. Now we have tested 9 meter. And we are also developing fully automated submersible cages. That later we will go into that. Because the advantage of submersible cages, you know that Andaman Nicobar is prone for so many cyclones and all. When there is a cyclone or something like that, these cages will go down to 10 meter or 20 meter. When the cyclone pass away, it will come up, so that we can have the fishes in a safer conditions. So there will not be any loss for that open sea cages or something like that. So those kind of testing also we have done twice. And suppose here you can see that mooring arrangement for these cages around in a mooring continuous mooring section, we can deploy around 8 cages, or we can go even up to 12 cages. But beyond 12 cages also we can go, but it depends on the species or number of density of species we are culturing, because they produce a lot of they produce waste also, that should be removed from the system. So we prefer to have eight number of cages in the size. Then after that, another after a distance of half a kilometer, another 8 cages like that we can promote in a larger system like this. Otherwise, also we can go up to 12 to 16. Also, we can go depending on the species we are culturing. You can see the cross section of that cage below. That how it is moved with that marker buys. You can see that marker buys inside there. Here, this is the photograph taken in that is in North Bay Port Blair. These cages were deployed around 2011, and still these cages are in good conditions. So we can we have done many number of experiments for fish culture. So we will see that. So we have designed these cages, and we have tested in different places, like open sea environment, like this Kottachitram in the Andhra Pradesh. This is in Olaikuda, Rameswaram. This is partially enclosed base, and this is fully enclosed North Bay. In all the bays, different bays, how it is functioning in the cyclonic conditions or in the closed environment, how long these cages will survive, and how best we can culture the fishes in these conditions, so that we tested different ways. And you can see different cages, different number of cages we have put. Patachitram 2 number of 9 meter, and Valikuda 4 numbers. Here 8 number in Tuplipalam, Andhra Pradesh, and here is North Bay in 4 cages we have tested. And you can see that there are 2 type of cultures. One is capture based culture, another is hatchery based culture. The capture based that the seeds for this particular cage cultures can be collected from the natural environment, that we can put it in those cages and we can culture the new fishes and we can get the profit. So seed cost, only collection cost will come. So seed development cost will be less. So it will be it gives more profit also. But in that case, whatever the seeds available near to the site or somewhere wherever we are getting, that we can put it. Whereas if you want to go for selective fishes, then we have to go for hatchery based seeds. That is called culture based cage culture. This is capture based cage culture. In this way, capture based in around the Mandam area, we have collected different fishes like that is milkfish, chanas, and there are scarce cobra that Gipon, that is parrotfish. These all we collected and we cultured. See, average weight was initially collection time, it is only 5 to 8 grams. Then it has grown up to 770 grams size in 260 days. And around 3.5 tons we cultured. This is the highest that time it was done. Later up to 5.5 tons we could able to culture in this system together. So this our secretary came and introduced the seeds during that inauguration of these cages during that time. Different fishes, milkfish and other fishes culture. Later we went gone for different type of that is culture systems. And this is in that we have found whenever we are getting seeds, it's all very small size. And these seeds should be reared in hatcheries till stockable size. So what we found it is very difficult to maintain the hatchery system. We have to spend a lot of money for that. So we designed our own nursery cages, small nursery cages, that is 2 meter diameter cages with smaller mesh size. So that you can that smaller seeds can be cultured within this 9 meter cages itself. So once they grow up to stockable size, the size of 30 gram or 40 gram, up to 10 centimeter size, you can grow in this and we can release that inside this big cages itself. So you don't need separate hatchery systems for this. So this is one advantage of developing, and we have proved this one in Andaman also. In other places also we did the same thing, and we could get good survival rate as well as, and we could harvest more number of this one. We can bring down the cost of the rearing them in the that is hatcheries. So this is what this is cobia fishes in that way. We have done it feeding. We were doing regularly with 2 mm size feed, and that is pelletized feed we use. This is if you see that 2012 we could able to culture in Andhra Pradesh around 1.5 tons of ASEAN sea bass, that is lateral scalp caliper. Later you can see that each one costing about that is farm gate price was around 325 rupees per kg, and it is around 300 gram size. If you allow few more months, it will grow up to 800 gram or 1.2 kg. Sometimes we could able to do it in Andaman Nicobar Islands also. And if you see this in triple column and different growth rate, based on that we can find out the growth rate was around 7.26 gram per day. This growth rate was, and we have conducted training also along with that. This culturing of the fishes in the different states. We have conducted the training. So for that, our previous ministers came and introduced the seeds and reservoirs, and they have given the motivated the farmers to take up this kind of activities. And this is the entire culture cycle of our Andaman Nicobar Islands. We have done. We have collected this 0.2 gram size fishes. That is maximum length is around 2.5 centimeter. This has grown up to 700 gram, 750 gram. This is sea bass, well, the latest caliper, and average size I am telling 700 gram. Even some of the fishes were around 1.3 kg. So that is a differential growth rate. So these 10,000 seeds were brought from SIBA, Central Institute of Practice of Aquaculture in Chennai, airlifted here, and within total traveling time, everything together, it was around 6 hours only. It reached even not even single 10,000 above, among the 10,000, not even single seeds died. We directly introduced into that smaller cages, and we grown. It is size is very small. We have grown up to that is 30 gram size. Then we reached into that bigger cages. Just we lifted and by tearing this one so that it can introduce. So whatever the culture we made, unfortunately that problem is everywhere it is happening. Poaching also was there at the end of the culture. So immediately we started harvesting. So we could able to catch a lot of fishes, and we have given these fishes to the local people freely, particularly fishermen. Then based on this different culture technologies, and the ministry wanted to find out where all this culture can be done in India, that is in Indian entire coastline. So based on 15 parameters, water quality parameters and atmospheric parameters, including depth, current temperature, salinity, pH, DO, like the different parameters, we have analyzed and find out, and we developed this GIS-based map and found out which are the areas suitable for cage culture in India. You can see that green colored pages are highly suitable, and red color pages are that is unsuitable like that. In Andaman Nicobar Islands also we have a lot of places highly suitable for this fish culture. Based on that, we have state-wise how much areas is available for the coastal environment for this kind of cultures. Like that, we have done. This is the submersible cages we deployed at North Bay and tested. And this is pier-shaped submersible cages. We have now tested one globular cage also. So in this advantages, as I said, whenever cyclonic condition is there, it will go down. and you can do the feeding when it is in top, and even in the when inside the water, you can you can feed them through pipe, and the central part is having one that is structure, that is the pipe like structure. In that you have to pump the air, and sometimes if you remove the air, it will go up and down. It is like hydraulic this one. It is you can operate from the boat or something like that. These things. So this kind of technology is already in one country, US based person. He is operating in that is Pacific Island. They are culturing cobia. So that will go up to 15 to 20 meter. Diameter is more than this room size. That is around 10 to 15 meter dia is culturing. So that kind of things we are thinking of in the future. Then the biggest that is difficulty in development of this open sea cage culture is availability of seed. So availability of seeds, if there are so much of seeds are available, then we can put lot of open sea cages. But this for this cage demonstration itself, 10,000 seeds we brought through airlifting. So we tried many times also, few times carry ourselves, we brought fishes and we could able to culture. But we realized that there is an important requirement of hatchery. So our we convinced our ministry. So now they have approved a hatchery for Andaman Nicobar Islands. Within our campus itself, this hatchery is going to come. It will be around 100-meter length and 25-meter width. It will have all the facilities for culturing marine fin fishes. Even if you want, we can go for sometimes shellfishes also, like shrimps. But mostly we go for fin fishes, like laters and cobia, many other fishes. And including, we have 17 hectares land area in our ANCA's campus. So in this, we are developing this one. Already we have given around 11 crore to CPWD for this purpose, and this design everything has come. Now we are going to modify little bit for our own local conditions. And this is the designs now we are finalizing. So after 2 or 3 years, I hope that this hatchery will be constructed and will start operation. And apart from that, we have done a lot of work on lobster patterning. This work we did it in smaller scale in Andaman Nicobar Islands, but mostly in Tamil Nadu coast we have done this work. And many of the people we have designed the cages and given to them, and they got benefited. Even some of the now also some of the people are practicing that patterning. Apart from that, macro patterning also we demonstrated in Andaman Nicobar Islands by developing different that is bamboo cages, iron cages, FRP cages, and nowadays recent system is within the room itself, vertical farming you can do. So crabs will be cultured in smaller box like that, smaller box. Each will have one crab, and water will be circulating like that. Within this room, this much area, you can have something around 200 boxes, and it will be cultured there. No, so this kind of systems. Now in China, they have lots of boxes and a very big this thing. They started culturing some, getting profit, and we may future bring this technology also. And this is the FRP type cages we designed for local and Pulicat Lake and other places we have given. And they now, as I said, this one will be this, let's say, this kind of box, which can be staked and we can culture this one. And apart from this, we have done a lot of artificial deployment for Tamil Nadu coast recently. And also for this work has been carried out for the Orissa government, and in around 750 modules of triangular, square, rectangular, and even bar shaped this one were deployed. I'll show the videos of this deployment. If the last of that small video is there, and this helped them that degraded areas, particularly many you know that trawling is happening in the coastal environment. It is degrading the environment. This whenever we are deploying in on some 750 numbers or 1,000 number of these rigs in 1 or 2 kilometers area, these people cannot do that trawling. We can go on fishing with the help of hook and line and many other methods, but it will protect the environment as well as it will help to develop corals and other algae and so many reefs inside. So thereby it is helping the fishes to grow in this area, and it restores many of the environment. Similarly, we have also, for the request of this Andaman Nicobar administration, fisheries department, we deployed this kind of fish aggregating devices. It is around 6 meter length pipe, PVC pipe, not HDP, high density polyethylene pipes. As we showed previously, our cages, which is also made up of high density polyethylene. So they last long. And this kind of things we have installed 28 numbers at Lakshadweep. Even fisheries department at Lakshadweep maintains this one. And surrounding this, the advantage of this one is the most of the fishes surrounding this area out of curiosity or something like that. So up to 5 kilometer range, you can collect the fishes. So the fish will be coming to this site. You don't need to go in search of fishes. In that way, while you are searching for the fishes, putting nets here and there, you will be using a lot of time, and you will be using a lot of fuel and all. When we are deploying this kind of these FADs, the fishes will be around that particular size. Over the period of time, within 3 months or 4 months, fishes will start that is developing in that area, and there will not be much that is appendages or something. It is only a tube with that marker lamp in the top, and also few appendages below. And it is specially designed in NAOT with it should float at the same time. The depth of that deploying area is around 1,500 meter or 2,000 meter. That is 2 kilometers. So that much rope length we have to put poly, that is PVC ropes as well as, and we should deploy using our ships or something like that. Similarly, for maintenance also we have to use our ships. It is little costlier, but in the long run, if you are seeing that, you will be able to collect a lot of fishes around this one. That's why Lakshadweep is still using, and many other countries like Japan and other places, there are thousands of FADs still in operation. So they are mostly using this. Few island nations, they are mostly using these FADs for collecting fishes. So in this around this one, smaller fishes will be near this FADs. Little bigger fishes will be around that. Beyond that 2 kilometer or something like that, around one FAD. So you will find very big fishes like bill fishes and tuna. This tuna actually travel one FAD to another FAD. It's like that they move here and there like that. It is noted also. And we are also for the recently for government of India is asked us to initiate so many seaweed culture programs. So in this we started doing that seaweed culture work in Andaman Nicobar Island, but we promoted only the local seaweeds which is available in our area. That is particularly Gracillary edulis and some other species in Gracillary also. And also we are looking for now edible seaweeds. This Gracillary edulis also edible, and the alva, another species that is green one. Then some more species are available which can be cultured in tanks. Those things we are looking after this culture technology. Now this culture we are also developing various bioactive products from this particular seaweeds also. You know that the only source of agar for any laboratory or industries or for jelly, what we are using, this is the only source. Seaweeds are the only source for agar. So wherever there are a lot of seaweed resources, but right now the major seaweed culture is culturing people are Chinese. They are in India, we are having different species. That is out of 244 species in Andaman Nicobar Islands. We have reported that is Pondicherry University has reported. Other than that, 1,115 species are available in India itself. Out of that, only 200 world over 240 species are commercially important. So they can be used for biofertilizer production. We are this some of the seaweeds which is available. This alva reticulata also it can be used for developing food, and this sargassum and many other species can be sargassum related species can be used for biostimulant production, which is helping the increase in agriculture sector. They are acting as growth promoters. So the culture, we are doing the culture by collecting from the natural environment. Then we are developing seed bank. Then from the seeds, we are promoting to different rafts we are dispersing. Then we are from there we are collecting like 30 to 40 kgs we collect from each this rafts right now. But in Andaman, that Mandapam and other places, they will the seed introduction itself around 30 kgs for each raft. So the growth rate will be around 5 to 6 times. So after 45 days of culture, you will get around 150 kgs of culture from the single raft of 3 into 3 meter, 3 into 3 square meter. But in Andaman Nicobar Islands, is very few places found ideal for culturing this particular type of raft type cultures. And there are different type of cultures like raft or open rope or even submerged cultures you can do. But in Andaman Nicobar Islands, we are mostly promoting this raft type culture. In that also, we have developed our own pouch method. We developed pouch method. There are tube. You can also fill them in the tube nets and pouches, and you can put inside that directly in the rope also. They will grow everywhere. But if you want to avoid the grazing by other organisms, you have to put separate net below that rafts, and you can tie the ropes like this. This is the smaller raft. That last one is. This is for seed development. Once they grow inside in this like this, you can see this is the grassularia release, and you can put them in small that is piece of net, then tie it like this. You can tie, and you can grow them in a bigger this one. This is particularly some one local variety of seaweed, particularly release, and there are other species also. We have, apart from culturing, we are extracting, as I said, various products from this microalgae. Particularly, one is fucoidy. This is used in a lot of that is pharmaceutical environment, pharmaceutical companies, and it costs very high even for that is milligram or gram level. It fetches many dollars. So in kgs, extracting in kgs, then imagine how much amount we may get. It is also used as anti-cancer product and many other immunosuppressants. Like that, so many other things are there. I'm not going into detail. And as I said, another plant biostimulant also developed from the Sargassum vitae and Sargassum polycystum, two species. And we tested in our own that laboratory environment, as well as we have given the biostimulant to carry people. Carry people tested in their own agriculture product, and they found it is giving good growth rate because it contains lot of micronutrients, as well as plant growth promoters like indole acetic acid, indole butyric acid, and many other products. So with that, it is promoting. It is also that is pesticidal properties it has. If you spray in the foliars that of plants, they will retard the growth of that pest over the plants. So similarly, we have developed edible biosheets that is from the seaweed. This can be used for making coffee bags and even food packings. You can use. You can you. It is like a bioplastic. It is a bioplastic. You can eat it. It is since it is not added with any chemicals to make this plastic. It is naturally we made, and it is not having any side effects or something like that. It is edible seeds. So this can be used in different kind of packaging, food packaging. This also we are working on that. Right now we have developed a few some seeds, and we are testing its tensile strength and how it can be further promoted. We are looking for that. And we do a lot of algal biotechnology, that is microalgal biotechnology, like seaweed. The microalgae also one of the very important. This one, lot of work we have done in NIOT, and also in Andaman Nicobar Islands is a collection point, and we do initial processing of this microalgae, which is less than 1 mm size. So they are found everywhere. They are the natural producers, that is primary producers of the sea. So you can collect and culture. There are so many species, thousands of species are available, and some are used as live feed. And we are using this microalgae for production of nutraceuticals, particularly which can be used in that is pharmaceutical environment, many other this one. And it can be used as animal feed also. And it can be used, you can see that spirulina tablets comes, no? This is the same kind of work we are doing. We have developed a lot of biomass from that. We have extracted oil. One of the oil is lutein, which is very much important in pharmaceutical environment, that is companies. Then apart from that, doing this work, we do seawater quality monitoring. That is studying the pollution in the environment, particularly in the Andaman Nicobar Islands. PORTBLAIR, we are having 8 sites, 7 sites, one at Wandoor, and we collect all the water quality parameters, temperature, salinity, pH, then microbial parameters, plankton, and apart from that, some fishes, many other this ones we are studying. Particularly in microbial, we do that coliforms, then other vibrios, many other bacteria, pathogenic bacteria also we are studying. So it gives us the status of our environment, that is PORTBLAIR, that is coastal waters, or PORTBLAIR, this bay waters. What is the pollution levels? We found out that one in 2 bays, particularly Phoenix Bay and this Jagrigat Bay, where that sewages are directly released into the these bays without any processing. So there we found a lot of coliforms and other microbial load. So other than that, due to tidal action, these are getting washed away. Still over the period of this 20 years, 20 years, we could able to find out various that is parameters, particularly temperature. There is an increase. Dissolved oxygen in the water level slightly coming down, and other thing, pH also increasing, worsen acidification. You can say it is also you can compare, and we can also say that there is a slight reduction in salinity of the coastal environment over the years. Over the 20 years, we can be able to find out. So this kind of continuous monitoring over a period of 20 years, 30 years, we can come up with conclusions about, we can relate them to the global warming, or this kind of data only supporting for that. So whether the pollution level is increasing or not, if you are saying, right now we can say that the pollution at PORTBLAIR-Bay environment is not alarming, like any other coastal environment in mainland. Whereas here it is controlled, but we cannot expect this to happen for a very long time unless we do some pollution intervention, that construction of this sewage treatment plants or these things. If you are continuously doing the releasing that this polluting that sewages and all, then there will be a bigger problem in the later stage, like disease spreading, particularly cholera and other diseases. That's a possibility. And we found out which are the areas the pollutants are there, and where are the releasing points. You can see these red dots are releasing points of sewages. Almost all the bays, even right from our mini bay to that abundant bay, there are a lot of sewage outfalls which is directly going to that. And this another work we are doing is that microplastic studies. You know that whatever the plastic released into the environment, they are by mechanical processes and weathering processes, they become the degrade, and even bacterial action also happening on that. Little bit they are also degrading. But after some times you will find this. So many microplastics will come into the water. This will interact with the phytoplankton, as well as it will go to the biomagnification process. It will go to smaller fishes. From that, it will go to bigger fishes. Then it will come to human. Like that, there will be biomagnification process can happen. We find three type of this. Microplastics, particularly fiber, and is more in this, and pellets also. Then smaller fragments. These three types are you can find in every beaches if you go on the coastal environment, along with the bigger plastic bottles and plastics. If you take the that sand and carefully, if you look into that, lot of microplastics will be there. Right now, this is the recent things for the past 30, 40 years. So we have even found these microplastics inside the belly of zooplankton. So they started consuming this one. What these zooplanktons are consumed by fish larvae. So if that is the case, what will happen to our fishing? Okay, in the future, this one. So right now we should intervene in this. So various studies on this one we have done. Even in PORTBLAIR environment, we could be able to collect a lot of microplastic, even in the gut. That is fishes. Some mostly in the gut right now. We could be able to find these plastics. They are causing cancer and many other ailments in the organisms, and it may cause the same thing in the human. And apart from the studying this environment, we have also undertaken cruises in Western Indian Ocean, as well as all along Indian, that is Andaman Nicobar Islands. We studied the plastic distribution in the surface to deep water area, and found out lot of plastic everywhere. Plastic, these microplastics are there everywhere. It is there. During that one, we found out lot of zooplanktons are consuming this one in the offshore environment. They are consuming whatever that cloth we are wearing. In that cloth we are using, we are washing it in our washing machines. From there, lot of fibers are coming. These fibers we are releasing into that land environment. When rain comes, this goes to that sea, and it is, since the weight is very less, and it spreads everywhere. Even we can find the microplastics in Antarctic waters, and wherever they are taking samples, this effect is there. So some kind of natural products, if you start using instead of nylon and artificial fibers, we can test them with various laboratory techniques, like what are the nylon, what are the plastics pointers here in different equipments like FI, the spectrophotometers are there for that. We can find out what kind of or what type of GC we can, especially it is there. We can find out what type of plastics, whatever plastics we are using, it is not going to go out of this environment like plastic bottles. This will be even last long in that environment, microplastic. So unless they float and come, actually these microplastics also settling on the sea bottom, and because it is coated with the microbes, and the weight will increase, and then when they die or something like that, slowly it is in. So we could able to find this microplastic even in deeper waters, even if you take sample from at a depth of 2000 meters. So which is not contaminated from the surface water. So how it is happening? So this is one of the interesting finding we have done it. Apart from that, this we could able to find this plastic degrading bacteria. We developed some 10 or 15 group of 15 species of bacteria which are actually degrading the plastics. Now we are developing this into technology. We have studied their properties of degradation using SEM and the scanning in electron microscope, and also in laboratory how much that is gravimetrically also we have tested it and find out how much low density polyethylene is being degraded, how much days it is taking. Around in 120 days, we could able to find this 10 group of 10 species of bacteria as a group. They can able to reduce about 47% of the total LDPE introduced. Then we found out how they are degrading. Then we found out a lot of that is deformities in the structurally that plastics and all. Through that we confirm that this plastic is also used by this bacteria as a carbon source, and it is degrading. So there is a solution for a little bit of plastic degradation. So this, if we can develop into a big technology, I think it will be a boon for future. Then we have developed another technology, that is mercury detoxification. You know that mercury, which is producing death in human beings when it is consumed or when it is accidentally consumed also. You might have heard about that Minamata disease happened in Japan due to release of mercury in the environment by a private company. And whatever the fishes that consumed by use this one, that is people use the fishes in those area, they got the disease of Minamata disease, and they got that numbness, and even death occurs. So what happened? This kind of polluted environment, mercury, actually, they can be degraded by the bacteria. Mostly the toxic bacteria, the toxic this mercury, methyl mercury, and many other mercury can be converted into its natural form, so that they will lose their toxicity. Okay, so that is the technology we developed. In that we found out this particular 10 species of bacteria which convert this mercury into its native form so that they will evaporate from that particular environment and it will go to that is atmosphere. So that particular environment you can remove that mercury. So this is another thing. Similarly, yesterday you somebody was asking about this oil degradation. So we have developed a technology for oil degradation using deep sea bacteria. So they produce some kind of compounds which is actually degrading this oil, and after some days, that is some 20 to 30 days, the percentage of oil, crude oil particularly, it comes down to from the original level. Like that, now we have patented the product and we have transferred to private companies. Similar things for this kind of degradation also we are working on that. And right now we have tested and we are successful. How it is, we could able to find out how it is degrading that particular toxic mercury. Then this one of the work we have carried out in this uncast. This is for the reduction of Enterococcus faecalis, which is causing that is endemic diseases in human beings. Suppose if you go to doctor with diarrhea and other stomach related, that is particularly this kind of diarrheal diseases. So to detect what kind of bacteria causing this one, it will take at least 18 to 20, 2 days at least to detect which kind of bacteria is causing this one. This particular bacteria, enteric bacteria, Enterococcus faecalis, which is normally present in the environment through which will come to us through eating contaminated food or something like that. So it will cause diarrhea, and we can detect them with this technology. We can detect them within that is 6 hours. That is, it is called a multiplex PCR, polymerase chain reaction reduction kit. We have developed that, and in that there are two things. One is development of medium, which helps the bacteria to grow within 3 hours. Otherwise, it will grow. It will take about 18 to 24 hours. Then you have to do the PCR testing, then purifying PCR testing. But here, once you culture in this medium itself, next you can directly go to next step for PCR, and within 6 hours you will get the results. So this reduction can be used in many other that is areas like food testing. Suppose whether this bacteria is there or environmental conditions, whether this bacteria, this kind of Enterococcus, pathogenic Enterococcus faecalis is there, like that. Different areas we can test it, and we have transferred this technology to one private company through NRDC, National Research and Development Corporation, Delhi. That is Government of India organization. Through that, we are transferring various technologies. So another microbial biotechnology, that is, we have collected this bacteria, Bacillus classy, which is producing a compound called ectoin. This ectoin is used in dermopharmacy. It is used in the face packs and so many other that is dermopharmaceutical product. In that, it is produced by a company in Germany. They are having the patent, but in India, first time, our group we have developed this technology. This is collected from a deep sea bacteria, which is collected at a depth of around 800 to 1000 meter depth, and it that ectoin from a gene from this particular bacteria was transferred to E. coli through molecular technology, and now we have optimized the production, and we have also these clones we are having now. These clones are being transferred to the private companies. Now they are going to produce this product and market it. So recently, in two companies taken these technologies from us. One is Cosmos Biotech and Amtur Laboratories Private Limited, Mumbai. Two of them taken this technology. Apart from this is another L-asparaginase, which is an anti-cancer enzyme. Actually, this is collected for this particular L-asparaginase enzyme is isolated from a species called species of Actinomyces called Nocardiopsis alba, and this is actually very good. That is anti-cancer and cancer agents. You can find this one in the market, but it is very costly. You can this particular product from our that is our lab, which soon we will be transferring to other companies. And similarly, next one, this is also another glycine betaine, which is an asparagine, which is also another technology. These are all mostly we use molecular biology technology. And there are other products like triolus, like that. So many other things they are working on that. Apart from that, we are also working on bacteria, which is isolated from that volcano, which is producing indole acetic acid. As I said earlier, it is one of the growth promoter. That also we are working. Then we have a lot of as I said, more than that is 80 environmental impact surveys, assessment surveys we have conducted over the islands, from Landfall Island to Nicobar, that is island. Then we do a lot of cruises, that is open ocean cruises. This water samplers you can see in that it is developed by NIOT. The specialty of this water sampler, which will retain the pressure of the particular depth. Suppose if it is 600 meter or to 2000 meter depth, 200 pressure will be there. That temperature of that particular area will be 3 to 4 degree only. It will retain the pressure so that you can bring it to laboratory. And we have other instruments. We can culture those organisms, particularly bacteria, fungus, from that environment, and we can do a lot of work. And many of the work I'm not going into deep of any of that. Just I'm doing all this. This is the map we have developed, and many of the local institutions or administrations have taken from us. As I said, it's explained by Dr. Previously by our forest official. This was deployed in Grub Island in Wonder Marine National Park, which is actually detecting various parameters, around 13 parameters. 10 years it is having, we are collecting this data. This also helps in detecting the coral bleaching event. During coral bleaching events, what is the temperature which is happening? Suppose corals which can tolerate up to 32 degree, but beyond 32 degree, if the temperature for few days, if the 32 degree persists, okay, it will survive. But if it goes beyond 3 days or 4 days, beyond 32 degree, then coral started bleaching. Normally, it is as previously said, it is around 29 to 20 to 29 degree. It will be safer limit, but beyond that, it will have stress. But at 33 degree, it will bleach. That too for a longer time. Then we are also collecting a lot of this gas sampling for studying this carbon monoxide, methane. This is one of the global that is study which is carried out with another ICR lab. In that, lot of that is air quality monitoring systems are there. This is 24 hours connected to the global network, so that you can see the carbon dioxide level in in world over how it is changing over the period of years. And this is the reference. This PORTBLAIR is a reference facility for that. Another reference facility is there in Himalaya. Another facility is in at Pujyate. We have three places which is being operated, and we have also done a lot of this scuba diving that is training. Then apart from that, lot of international conferences also we are conducted. Apart from that, we are also managing our high frequency radar, which will help us to detect the tsunamis and the various environmental coastal environmental events, which is located at Rangachan and as well as in Hadley, which will give you that warning through INCAIS, and this data is going. It will give within 400 kilometer. You can analyze the pattern of currents and the wave patterns. So based on that, it will detect the tsunami arrival and all. So it is one of the system we are monitoring. These are cameras, and if you have more doubt on our activity, this is one of the small activity. One 2-minute video. Okay. Thank you. Thank you for giving me the opportunities. Anyway, I will not go deep into that because it is very lengthy. I have given only glimpse of the activities what is given. There are so many activities we are working along with our various institutions. So we are always welcome for any collaboration or any support for the students. Thank you very much.
We'll discuss in detail.
Yeah.
Thank you, Dr. Vinay. It was really an eye-opening talk from your side. You have touched from cage aquaculture to fattening of mackerel and lobster, then seaweed farming and marine pollution monitoring, then isolation of various compounds from the algae, bacteria, other organisms. So it is all a mind spinning activity for the people. It really enhances the livelihood options. I have also seen from the slides a lot of patents have been filed and got for NIOT. So that way NIOT is doing a government service for the coastal communities of the island. So with this, I thank you all. Our session comes to an end. The next session is going to start. Thank you for giving a patient hearing and listening. Hope some of you, all of you, should take some take-home lessons and try to build on whatever input that you have got from the morning session. 3 sessions, 3 talks have been conducted, and all 3 talks, a lot of new things have emerged. Hopefully, it will be very useful, particularly for the college students. But for school students, it will be an added knowledge base. But college students, definitely, you can use it for your career progression and furthering your career. Thank you very much. We are running short of time, and we'll go to the next session. So we have with us one of the most experienced, versatile personality of DRDO, Dr. Sukumaran. He has worked with DRDO for more than 3 decades. They had contributed in the field of defense sciences. So, floor is yours, sir.
Good afternoon, everybody. I think after a hectic lecture on aquatic line, so I'll be taking to the terrestrial line. So I'm a Dr. Sukumaran. So I was in DRDO, I joined director, I retired last year. I'll be telling about the innovations by DRDO with reference to entomological products and technology for Indian armed forces. So many people must be thinking what entomology is doing in defense. So I will come by one, and so that you will come to know by yourself. So the first thing is, so DRDO, this comes under Ministry of Defense, and there are nearly 42 labs are under different clusters, and every cluster has got its own job, and the cluster is headed by Director General, and headed by labs are directed by directors. And every, as it were, aeronautical, naval system, life science, microelectronics, computational system, electronic communication, armaments and combat engineering, and missile strategy. These are all national defense. So this is a very prestigious organization which is doing research for DRDO, it's for Ministry of Defense, for armed forces. That includes Navy, Army, Air Force. So for all the things, we do different. So you must be knowing what are all the missiles. So Dr. Kalam is a missile man. So he was our head, and I will be telling this. So these are in brief. What is the area of work? I think the first is Dr. Ganesh would have told. I don't know how many of there, but these are. I'll share the slides in the future. I'll give it to them. And these are, as I told, the different clusters. And my cluster comes under the life sciences. The life sciences, the charter of duty is biodefense, NBC detection protection, life support system, personal selection system, nuclear medicine, high altitude, agro tech, and nutrition and food technologies. So, and this is I told you, this is Defense Research and Development Establishment Gwalior. This is the only lab which is authorized to work in the detection, protection, and decontamination of chemical and biological warfare agents. And because, why would there be chemical warfare agents? Because the man behind the weapon is very, very important. If the man is not there, no weapon can be operated. So our armed forces, they are divided all over the different terrains of India. So they have to be protected. So I'll come to this. If you see this slide, one slide, you can understand what is the importance of entomology. This one slide can tell which is the world's deadliest animal. If you see, this is the data given by WHO. You can see the mosquitoes, they are the maximum, they kill the maximum number of men. They may be very small, but they are medical insects. Not only insects, there are other medical insects of valves. I'll show them also. They kill. Next is human, maybe terrorist or other bomb blasting, all those things. If you compare to all other, this one small mosquito, they say sometimes we laugh at the mosquito, but when they are on job, it may be dengue, chikungunya, or whatnot, malaria, all this. So then only we cry. Human cries there, and I'll come to that. So what is the importance in armed forces? This, as I told you, Indian armed forces posted in different parts of India, they need to do protection from these arthropod workers. And one saying is that more number of casualties of soldiers occur due to the disease and non-battle injuries as compared to direct war injury. So the soldiers sometimes need to be evacuated, and the bites of arthropods can cause discomfort and distracting. when they are on the operation of it may be a bee or it may be mosquito, whatever, they will get distracted. And routine training exercise, everything has to be, it will get during the operation, disaster assistant operation. They have to be protected. So they are mostly the army comes in whenever there's a natural disaster, something like army comes for a rescue. And the reason why the maybe a reason for increased vector borne disease may be decreased sanitation, poor hygiene, overcrowded living conditions, stagnant waters, uncontrolled use of chemicals, and to control vectors. So these are the one of the few reasons. So I'll come to the next slide. So this is what I want to tell the importance of medical importance. See, our armed forces, they are sitting all over the borders and they are securing for Mother India. That's why we are safely and happily we are sleeping here. So when they are safeguarding, they are being, their diseases are there due to mosquitoes, sandflies, insects everywhere. Where are they? So first they have to protect. So as an entomology, my job is to protect the man. And of course, the chemical biological warfare is there. But as an entomology, my medical knowledge, so I have to develop some products which are very useful to the armed forces. That's why I'm there. If you see the medical insects, these are the mosquitoes or vectors. As I told you, malaria, chikungunya, the many major vectors they are. So other one is the vectors which are ectoparasites. That is, it may be lice, it may fleas, ticks, mites, this is bed bugs. These are the things. So it may, and even if the sand flies, black flies, sepsi flies, horse flies, they are all causing the different kinds of disease. So all our armed forces they are prone to this kind of diseases. So they have to be protected from all this protection. Not only for blood sucking, non-blood sucking. They may be cockroaches, they may be mechanical carrier, or they may spoil their fruits and houseflies and mites, screwworms. These are the different medical entomology. If you see, as compared to all other diseases, and so malaria takes nearly 22% of the day. This is the WHO record on an average. As compared to other diseases, left other diseases are very less, but malaria is so. If you go to the different parts of the world, every place that has one or other disease which is very prominent there. So we have to see which area where what type of diseases are there in India. So we have to take care of that. So many of, as I told you, the importance why many of these arthropod vectors are potent biological weapons and which can be used intentionally for disease transmission. So along the border area, they can release the infected mosquitoes or infected and they can silently they go away. The result will come only after when the disease is prevalent. So that is the problem. So there is one book called Six Live Soldiers using insects weapons of war. So there is James Lockwood. So the what they say biological warfare agents, they are living organisms or the byproducts of living organisms that cause disease that lead to incapacitation of death. And sometimes you can't see them, but you can smell them, and you can taste them also. So silently they will be there. That's why biological warfare agents are more dangerous as compared to because chemical you can see right now. So I'm not touching that chemical and biological warfare because due to the constraints of time, I'm concentrating only on entomology. Since I'm a medical entomologist, if I start talking, no time. So I'm rushing. Please bear with me. If anything is there, you can discuss me afterwards. So how this direct insects level is. From that book I collected. These are the insects as this your weapons in war. Maybe in the Mesopotamia, it's a history. African tribes they use, Mayas used, and they were ancient Greeks people they have used. That they use they put in take it in a basket and throw on the enemies. So to immobilize or drive away them, they use these are the records is there. These are all recorded ones. What I'm telling is not a thing. So even the dumping bees as a bees, the defendant, and even they devastated by infested fleas also. So Napoleon army during invasion to Russia, more than 2 lakh soldiers he lost due to typhus from lice. And during World War One also, different places they were recorded use of this all this arthropod vectors as a directly for contaminating as a biological agents for disease transporting the disease. They once a criminal war showed that diseases are deadlier than the bombs or bullets because number of deaths have happened due to that may not be happened that due to bombs and bullets, but silently this biological warfare is killed. So passive metamolecular warfare of mostly insect borne among enemies continued many war. So as I do World War II, Japanese and they were there one place called factories of death they call it is. In Japanese War Ministry sanctioned a gem warfare research control. They say factories of death. Anybody goes, they will not come back. Any soldier they arrest them, they'll take them, they'll test them. They are so cruel because they want to test the other war people and they want to have the result. So they'll be recording how to what happens, all those things. So that's why they call it the factories of death. Then even the UG bomb, see 1 lakh people died by dropping this infected insects, and even 2 lakh. See, there is a number of these are all recorded ones. That's what I'm telling you. And even US Korean War also they are dropped many times. These are silently it goes. Even nobody knows. I think this time we are having that war scenarios going on. But nowadays the entire war is totally different. These are all recorded in one. Now it is totally different. Things are maybe using the chemical operations or any other. But what happens only after record only will come to know that. Until other people record it will not come to know that. So even that what they'll do, they'll release the insects to damage your food crops. They'll damage your food crops so that you will not have enough food. So this is another incapacity in the army. As far as India is concerned, there are unique susceptibility of in country black biological warfare and threats are there, where the geography weather is condition provide faster propagations by biowarfare pathogens, higher population density is there, and lack of proper infrastructure. All possible vectors are available here, and no effective policy is yet established to handle bioterrorism or biowarfare. The possibility of media involvement resulting anything small happens, they will have it, they will create. Every will throw the media and all people, it must be plague and all those things. They create it. So that is the condition. And diverse socio-economic and cultural variation, different types of people, and malnutrition of human system, and unhygienic condition. So all these things they show India is vulnerable for this kind of attack. So what we did in DRD, I'll be talking only on the products what we have developed and what their present condition. I'm not going to tell everything in detail, so that in future if you want I can discuss it. So this is the called some few products that's called DIPA diethyl phenyl acetamide. This is an insect repellent cream. There is a this is equivalent to diethyl amtolumide. This is this is golden standard for insect repellent. This we have to import from USA. So instead of that, we identified this compound called DIPA, and now we have developed this compound, and now it is in the form of spray. It is supplied to army. And other one is a slow insecticide paint. In naval ships, lot of cockroaches and other things was there. So there was we will do research only as per the requirement of armed forces. It may be Navy, maybe Air Force, it may be Army. So we have to do only. It is not that any study we can do. So that a slow release paint they wanted because every time we cannot paint. So whether we can develop paint. So we did. I'll be discussing that also. And atracticide as an outcome of our research, scientific activity, we developed some. That is, it is a very specific to dengue mosquito. We just keep that, they'll come and they'll get attracted. And the other one is a wool care. It is a wool care spray. So army uses a lot of excuse me. Army uses lot of woolen cloths. So wherever they are high altitude, when they after use them, when they store it, lot of insects they damage. Even a single hole in a blanket or a coat or something, everything goes west. So that is also for that also we developed a spray. I will be doing that. And another one is a ratax. Every day rat is the biggest problem. In naval ships, we want a rat because we cannot find it. Main problem is that the rat will die. It will go into the AC duct, and then it will purify. The smell will be there. They want to avoid that one. So they asked skill. So they wanted some compound. We identified some compound. We developed it, and it works very well. I'll discuss that also. Another one is a nicotine nullite. You know, nicotine is a molluscicide. Molluscicide is used to kill the snails. Snails are the intermediate host of schistosomiasis in animals. That's called animal schistosomiasis, where animals' belly will encourage, liver will be damaged, and the efficiency, working efficiency will be lost. Because army uses a lot of horses and mules for transportation high altitude area where motor cannot go. So that area for that this snails they were acting as an intermediate host that has to be killed. So we have identified some compound that also I will discuss. Another one is the canopy drug. In Bhubaneswar, Nandan Zoo, there were death of white tigers, 12 white tigers which created havoc. And when the zoo authority were they were looking for some help, so they approached us. We assisted them, and we could control the white tigers. That also I'll explain. So as I told, this is a diethyl phenyl acetonide. It's a compound, and it is very clear, faint and good, practically insoluble. And this is a characteristic feature. And if you see the efficacy of this DPA, it is effective against all most of vectors. As compared to DEET, it is almost equivalent. And this is the DMP which was earlier used. Now we have replaced, Army was using that. Now we have replaced the DPA, which is almost equivalent to this. And this it is very effective. So this actually what happens whenever we develop the DRDO develops a product for the use of army, it should be invented, it should be introduced into the inventory of armed forces. Then only we can go when every year they will buy on their own, and this DPA it is being purchased regularly. This is the toxicity rate. As per toxicity, this compound is very safe, and for all different route, oral, dermal, inhalation, mutagenic, it is safe also. And this is the different formulations of DPA. This is a DPA, and it is a spray. Now this spray is being supplied to armed forces. For we tried for the technology has been transferred to many companies, and they are supplying to armed forces. And in between they were trying to sell it in the civil also. But our concern is mainly armed forces. Every year nearly some 8 to 10 crores rupees sprays they are buying army every year for supplying to them. This is the cream formulation as compared to it is so we are about to introduce this also. The spray is introduced in the armed forces. They are supplying. As I told you, this is a slow release insecticide paint. So one story is that this DRD we developed the paint. This some 15-20 years back my seniors they developed, and because they wanted a paint which can release insecticide from that, and the chemistry is so delicately balanced, the sufficient quantity of insecticide for killing it comes on contact with it. The efficacy is 2 years completely, and they conducted extensive trials in naval ships, INS Vikrant and Kanjar, Rajput, and even Rajdhani also. And they said, yes, it's excellent. This product is excellent. And afterwards, this is 2 years effective. And this is the ready-to-use formulation. There is no need to dilute, and straight away you can use it in kitchens, restaurants, bars, hospitals, everywhere you can use it. But when I took over, when I became the head of the department, I wanted to push this product. This was not introduced in the armed forces inventory. I wanted to push it. That time they had maybe said, sir, this is the old trials, I want new trials, but the requirement is changed. What requirement? Government said all the paints, it should be less than 90 ppm. Then only you can, it's a gazette notification is there, 2016. They said it should be. And Navy said, nice sir, this paint I want fire retardant strip, slow release paint. It should be a fire retardant. So it is oil-based paint only, but it should be a fire retardant. Okay, that also. Then I took time, and new paint, that is a Mark 1, this is Mark 2. We made it a composition, that is deltamethrin, chlorpyrifos, and pyriproxy. It's an insect growth regulator. At this particular combination, it works very well. So we did this one, and even the CPSC guided in the animal house we tried, skin irritation showed it is very safe, and the oral toxicity also it is very safe. So now my trial is I have to take it to the next level, and unfortunately I retired in last 20 February, but due to Corona I could not proceed this one. Anyway, I given to my juniors, and they are in the process. I am still contact with them, and I hope sure I'll come back. I'll come out. The kinetic study of the paint showed it is applied at the 820 square per kg and is tested in the lab. This shows that even almost even 24 months application also this paint is very effective. This is a laboratory study, and as I told you that the insect growth regulator, the beauty of this compound is insect growth regulator. This is the normal development of Aedes mosquito eggs. So before blood meal, after 18 hours, 24 hours, 72 hours, 24 hours, 42 hours, 72 hours. So we'll get a black eggs. So any mosquito takes a black, minimum needs 3 days to digest it. Digest and for making a to give out the egg, it needs nearly 72 hours. Nearly 48 to 72 hours. So this is the normal Aedes mosquito. Once if you treat them, what happens as compared to control, you can see the stunted growth. There is no generation will not be there. Even if it is the resistance problem is there, even the mosquitoes become resistant. That is the biggest problem nowadays. So they'll get a resistant and so they'll not. We have to increase the dose. But if you use this paint anywhere, any kitchen, hotel, hospital, wherever you come, once apply and forget 2 years. So the trials, our laboratory trials are excellent, and this shows this study shows then the next generation will not be there. And the shelf life, as per estimated, was a real time, whether it is a deltamethrin or pyriproxyfen or chlorpyrifos, it is almost comes whether our estimated real time values are almost equal. And this shows that 24 months, this is more than 24 months, this can work. So I am very much hopeful about this paint, and it can be. As I told you, another product that is atracticide. This is only for Aedes mosquito. Aedes aegypti mosquito, which can attract. That is the Aedes mosquito. They lay eggs in the water lab. Once they lay eggs and they hatch, egg ones hatch. So what happens? Wherever the animals, more animals are there, the Aedes again and they go and lay there. So we filtered the larvae and we kept the plain water. Again, she started laying the eggs. So we found that something is there which attracts her to lay eggs. So what we did, we analyzed this compound. This is mask. We found that this particular C21, this compound said it is very much effective. I mean, all different fractions. This was showing very effective. So even we compared with the sigma standard compound, and if you see that as compared to control, that is a blank. That is a C21 plus IGR. It is attracting more eggs. So what happens? The female will come lay, and once they hatch, they will not develop. This is the thing I will be published in paper also. And the pheromone, it works as a lurinical phenomena, and this formulation balanced combination of ovulation attracting pheromone, IGR. IGR causes hormonal balance in larvae and does not allow to transform to adults. This is indigenously available chemical, and it is a patent also is there, and the European patent also applied, and we got it. This in 2008 and 9, there was a municipal corporation of Delhi that whenever there is a dengue is there, people will look some help from there. So that time they wanted they said whether you can do some trial. We conducted in many places 2008 and 9, and even the Commonwealth time also we conducted successful trials based on the encouraging results. A multi-centric trial was conducted in March 11 and 12 at different urban and rural area. Bangalore, Delhi, Alappuzha, Kerala, and Pakistan for feasibility of atracticide for surveillance and control of Aedes mosquitoes. So the trials were conducted at different places, Bangalore, New Delhi, Alappuzha, and the final reports of National Institute of Malaria Research, they say the C20 atracticide works very well, and they can play an important role in surveillance where more atracticide as compared to control, and the experimental overdraft, there is no formation of people. This is a beauty thing. And the studies indicate atracticide has a potential for surveillance and management and as a component of integrated vector control program. So these are the advantages of this atracticide. As I told you, that wool care, a moth-proof spray is an Indian Army. As I told you, it uses a lot of woolen garments for insects like woolly bear, carpet beetle, and other moths. They damage in a huge way. A lot of successful trials were performed by using this spray for it is a permanent based one, and for protecting them. And the exercise and efforts are being taken so that this also can go into the Indian inventory. As I told you, this is the red tax. The beauty of it is that it was a requirement from Indian Navy. They want to kill the rats and to avoid any smell in their AC ducts. And this particular compound, this fluorostamide, is a very highly toxic compound. And even we made a cake and it can be used. The problem with this compound is you cannot leave the bait there. And what happens once the rat nibbles it, it will paralyze immediately, maybe within a few minutes or something like that. And you can visibly, and if you keep it in the room where rats are more, the bait, you either mix it with atta or something like that, or even plain with water also, but it's a very toxic compound. And so you have to try the compound also, you have to dead rats also. Because the problem is the secondary poisoning is there. Any snake or any birds they eat rats, they will die. Or our baits, if any cats, any animals, dogs there, so they're dead. So it is a very dangerous compound. So earlier China, now it is banned all over India. All over world, sorry. Because you cannot use. Only but restricted. Under surveillance you can use it. So for armed forces we use a lot of wires and all this, cables are now. So they'll cut the cables, instrumentation, so everything is there. So suddenly missile cannot go or something, everything you have to protect it. So there you can do it in a controlled way. So it will definitely work. The other compound I told nicotine only, it is a fresh water, they act as a vector of animal sustenance, and because they are efficiency, they are losing the efficiency of horses and mules. And there is a benefit I said one compound recommended by WHO. They recommend this one. Yeah, even at a molluscizal concentration, it kills the snails. Molluscizal, it kills a fish. Sorry, they said that fish can be consumed. There is no problem. But the problem, we wanted to identify a new compound. We identified this nicotine light, and it works very safe as compared to Belicid. It is almost very safe. It is safe towards non-target organism against fishes, everything. Whereas the Belicid is very toxic to other organisms. But it is recommended still by WHO. So my PhD thesis was on this, the mode of action of this nicotine light, how it really goes, how it kills, how long it takes, what are the metabolites, and those that I did my PhD, I got my PhD. This canopy trap, I want to tell you, as I told you, in the year 2000, Nandankanan Zoo, 13 tigers were died due to trypanosomes. And the DRD is designed and used this terminate traps for trapping horseflies and terminate flies, affecting horses and mules maintained in breeding station. Hathigat and Babu, there's a place where thousands of horses and mules are. Because they crossbreed horses and donkey, they get a mule, because so that they can carry a good number of litages in unmotorable route. Wherever everywhere you cannot go by road. So there for that they breed, and even for the sports and all other purposes they got. So there what happens, wherever the horses are there, so this problem comes. So we develop this kind of a trap. So once what happens, Central Geo Authority of India, Ministry of Forest Management, they approached DRDO for any control of measures, because all over there when the 13 tigers, all over India they were searching for them. So when they approached, the DRD team visited Nandankanan Zoo, conducted IPM for the control of integrated pest management for control of flies using Butox, is a compound, and application formulation, and residual or the KO3. This is the integrated pest management suggested by DRD, and it has been recorded to the Zoo Authority. It has been input. I don't know how many places it is being followed or not know. And we could control the trypanosomes. This has been in the Indian Zoo years ago also there. So this is what I just want to tell. And thank you very much for due to time. I had to rush, otherwise I would have given a full detail. I'd like to thank under Azadi Amrit Mahasam, Minister concerned in collaboration with Vigyan program. They are celebrating this Vigyan Sarvatra Pujyate program. And I wish to thank the officer inside, Dr. Sarvatra, for inviting me to give a deliver lecture, and ZSI Director, Dr. Diti Banerjee, for arranging all these things. Thank you so much, sir. Thank you very much.
on behalf of the coordinator and Government of India, I'd like to extend the thanks to Dr. Sukumar. So it was indeed a very pleasant lecture, sir. It's really a different lecture because DRDO to our mind it comes only to the weapon. So it never thought of like even the biology is a component of it, and it is a really enlightening thing for the youngsters.
Yes, sir. That is my
Yeah, and this is one organization which is a flagship organization in the country, which caters to the demand of more than 2.5 lakh armed forces. And really hats off to such scientists who are protecting them for taking safeguard of the country. So it's really a wonderful thing, sir, and happy to have you here. Thank you very much, sir.
yes. We will write the director DRD, will get everything. Spray and all everything. See, everything is available. Thank you so much, sir.
So for the next session, we have the zonal director of Fisheries Service of India, Dr. Vinod Kumar. He has 26 years of experience in the marine fisheries. He has expertise in stock assessment of marine fisheries, biology, and taxonomy, and he is specialized in DNA barcoding of marine fishes. And he is a recognized research guide by the University of Mumbai for taking the research students. So he has joined and he has taken over the zonal base of PORTBLAIR. And
Only last month.
yeah, last month, and we'll have his company for quite some time, and the floor is yours.
Directly, how we gonna come? 30 minutes, I have to put on otherwise, money.
Oh, at last I got the time. Respected chairperson for this session, Sri P. Naveen Kumar, IFS this year, and respected chairperson of morning session, senior IFS officer, Dr. K. Raghunathan sir, and Mohanraj sir, Vinit Kumar sir, and Sudhakaran sir, and especially this officer in charge, Dr. Siva Peruman sir. Not only the eminent personalities here, my colleagues, my dear students, and actually since morning, my colleagues and Mumbai University biology faculty members of MITI also on the line since morning. They are waiting, and for them also thank you. And my classmates from Andhra University also, they are watching this YouTube live telecast, so they wanted to listen to me. First of all, I must good evening all of you. I don't want to take much time. You will enjoy my lecture because I worked as a lecturer. Of course, any person will have tolerance of 45 minutes brain tolerance. Normally in a college or school, lecture 45 minutes, for discussion 15 minutes. Now my lecture will be very interesting. I will give you marine fish to enjoy, to play, to understand. Now, I'm very happy. I, being a geologist, I feel that it's a great privilege for me. I'm a part of this wonderful program being organized by JDSI. Really, as part of to commemorate India's independence, 75 years independence in the country, Azadi Ka Amrit Mahotsav. Lot of programs are being organized. But last month only I joined here. The moment I joined, third day I got the letter from JDSI officer in charge that you have to come for a meeting. I was surprised. I'm new to this place. Even then, I told I'll be coming, sir. Then I came for a meeting, and then I came to know that, sir, we are organizing one science festival, and we discuss about innovations. We discuss about what is that? What do you call that? Innovations and inventorization, and many talks, around 21 talks so far. Everybody, eminent personalities have delivered like talks. I could listen to them, and certain things I have not known, and certain things known to me. But today, Forest Officer sir has given very wonderful talk, and really it was inspiring. I don't know, I'm new person to this Andaman waters, so I could see the resources, the birds, the crocodiles, the reptiles, everything. Really, it's a wonderful event for me, and as part of this festival, in a nutshell, I just will say, and I'll go immediately. 15 minutes I will take. I don't want to take much time. I will show you videos also. This is to discuss SNT achievements, science and technology achievements. What has happened? What is going on? What are the institutes? What are the things they are doing till now? And in coming days, to reach to 100 years of independence, what scientists, what the future generation, what they are going to do, that we are going to discuss. We are here for that only. We have done. When we were studying, we don't have computers. We used to type on only type machine. For research also, we have to reference. We have to sit in the library. We have to read. We have to make our own draft. Now computers have come. Android mobiles have come. Smartphones have come. Everybody is busy with Google. If you click, you will come to know what has happened, what I can do. That is happening. So the ZSI has made this program 75 programs, 75 radio talks, 75 lit events, 75 books released, 75 posters, 75 awards, 75 films, 75 lectures, and 75 expositions. I'm very much proud that my lecture also added for this program. So now, in this endeavor, see, I acquired some knowledge during 26 years of research experience in marine fisheries. Whatever knowledge I acquired, I should share to the future generation so that they do something. Likewise, the Director General of our organization, Dr. J. Bhaskaran, was the product of JSI. His expertise in coral reef ecosystem. He started his journey from Andaman waters in this JSI. He has contributed a lot to the science. That's why he became Director General of our organization. Second, we know that Kalpana Chawla has gone to space. Now this JSI director happened to be a lady, first lady of JSI director. So ladies are here, that's why I want to inspire you all. Ladies are having power, so we can do it. So Madam is an expertise in entomologist. Now come to our officer in charge, Dr. Siv Parwan. He has contributed, he is the best ornithologist in the country. Do you know? He's the best ornithologist in the country. He has contributed more than 270 papers, 38 books. He has gone to three months Antarctic expeditions. This program is made successful because of his full effort. So such a wonderful person's wonderful contributions. JSI is having wide area of research exposure. Maybe reptiles, ornithology, avians, amphibians, everything. But my organization also completed the Fisheries Survey of India, 75 years of journey. During 75 years of journey, we are also celebrating. So, India independence, after independence, 75 years is completed. Our institute also completed 75 years. So, in view of that, the institute, what is the role it has been played so far, and what is the role it is going to play in future, I just want to tell you. How many of you know about Fisheries Survey of India? No. Yes. I also felt that earlier when I have applied during 90s, early 90s, I thought Fisheries Survey of India was part of JETSI. When the advertisement has come in the Union Public UPSC, the employment news, I just see. I thought it is a part of JETSI. Then later on, I came to know that Fisheries Survey of India is separated. It has established in the year 1946. Now, my topic is, I'm going to directly to my topic. Topic is role of Fisheries Survey of India, its achievements. It has established in the year 1946 as a deep sea fishing station. Till then, no historical data of any fishery in the country. Till 1950. In the country, marine fisheries, about marine fisheries, we don't have any history. Then, in the year 1946, deep sea fishing station was established. First surveys conducted in 1950s on Mumbai coast in the continental shelf region. Have you heard about continental shelf? No? Continental slope. So as you are students, I want to tell you in a teaching way. Continental slope shelf is nothing but a gradual slope of the land from the shore to up to depth of 200 meters is called continental slope. Beyond further slope deepens go to up to 500 meters called continental slope. So most of the fishing operations are being carried out in Indian waters up to maximum fishing pressure is up to 70 meters at so. What lies in it beyond continental shelf, nobody knows. First, we have to have the understanding and know the resources availability in the continental shelf as well as continental slope and beyond 500 meters oceanic gravity. So the FSI started its journey with a mine sweeper, which was it is a stern trawler, ST Meena, which was that name was when it was given to Fisheries Survey of India in the year 1947. It has established. We used to collect and go to landing center. We used to collect the data. Our scientists used to go and collect the data, how much catch is landed, everything. Later, the Berar one Navy vessel was given to Fisheries Survey of India. That Berar name, we have changed the name called Meena. Stern trawler Meena, ST Meena. ST Meena, that length was 153 feet. It has having a capacity of 35 tons. Fish can be stored in the fish hold. -1 to 0 degrees centigrade. That vessel was given to us. This history nobody knows. I collected the big for preparation of this one. I have to do some collections. That's why I could collect it and I'm able to give you the information. Then thereafter, Sardinella, one species name, that is Indian oil sardine. Indian oil sardine. In the name, by that name, one vessel was purchased and given. That was 10 meters. The FSI started first 153 means 153 feet. How many meters? I could not. So 10 meter length onwards. Now we have reached the level of 40.5 meters length. Many of the vessels, Meena series, Meena Bharati, Kalyani, Meena Prapi, Meena Prayas, like that. Then up to 1974 to 1983, all these vessels, 17.5 meters vessels, we used to operate. Scientists never used to go and collect the data. We used to collect the data from the landing centers. We don't have the facility of scientist cabin or something like that. Thereafter, various structural, functional changes taking place as R&D activities have been changed, elevated, and then they renamed as a Fisheries Survey of India in 1983. With the induction of larger trawlers from 35 to 41 meters length, having 100 tons capacity. Now you can see. This is the first mandate which was given to FSI when it was deep sea fishing station. First carry out the exploratory survey, collect the data in time and space, latitude wise, depth wise, coast wise. We have to collect. Half Andaman waters, what are the resources available? In demersal, bottom dwelling, what are the resources available? Midwater water, what are the resources, columnar waters, and deeper waters, oceanic waters, what are the resources available? We have to collect. Then afterwards, we have to train the personnel. fishermen. Then afterwards disseminate the information. Then we have to fabricate and experiment it, and we have to tell the fishermen that we have experimented it, it is found very successful. You make it and you fabricate it, you use it, you will get the good harvest. This is 83. Since FSI established in 1983 till 1996, this is the mandate was given. Major objectives of this organization was survey of fishery resources and charting of fishing grounds within the Indian EEZ. And we have to fabricate and we have to experiment, craft, gear for deep sea and oceanic fishing. Then monitoring of fishes, because certain fishes, certain area. This month we have surveyed one area. Next month, the same area, if you are going, that fish will not be there. Why it is not there? We have to monitor whether temperature is not there, salinity, environmental conditions are not suitable, or food is there, food is not there. That we have to find out. So for that, we have to understand whether declining, where it has migrated. That studies we have to conduct. See, training to fishing operatives. So survey of inland fisheries also given because of some constraints which we could not take up. And whatever data we are collecting, we have to disseminate to the fishing industry, fishermen. In regional language, Tamil, Telugu, Bengali, Orissa, Malayalam, every language we have to translate, we have to give it to the fishermen. The data which we have collected by our vessels should not be kept with us. We have to disseminate the information so that they can save the time, they can save the fuel, they can save the energy. Directly they go to the fish landing center, fish where the fish grounds, they can fish there. Now, up to 1996 to 2002, again, evaluation committee is there. One evaluation committee every 10 years, they evaluate the work, and additional work need to be given. They will allot the work, and according to the evaluation committee constituted by the secretary, the chairman of Ministry of Agriculture. This department, since beginning, first started its journey with Ministry of Food and Agriculture, then Ministry of Agriculture, then Ministry of Agriculture and Cooperation, then Food Processing Industry, Ministry of Food Processing Industry, then Ministry of Agriculture and Farmers Welfare. Then later on, now presently in the year 2019, new Department of Fisheries was created, new Central Ministry was created, Cabinet Ministry, Ministry of Fisheries and Animal Husbandry in Delhi. On 5th February 2019, new ministry established. Thereafter, our mandate, our activities totally changed, and it's going to be updated. This is the mandate presently from 2007 onwards. This is the mandate. Stock assessment, revaluation of potential, what lies in the sea. Every 10 years, a revaluation committee, potential estimates are made by the revalidation committee. The committee every 10 years, they will sit, what are the catches, earlier catches, they will calculate with the statistical tools, they will arrive at some figure, this is available, how much we can harvest, how we have to maintain the sustainability, what are the conservation management measures we need to adopt. These are the things we require. We used to derive the strategies, and we are involved in a lot of policy formulation and implementation of Government of India. Now, fisheries at a glance. The present data I am giving you, you can see the area of coastline, this and all you will get from the Google also. Marine present production 3.73 million tons, inland 10.48 million tons. You can see the production potential. Potential last 2018 only we have estimated 5.31 marine fish potential and 10.43 inland fish potential. You can see how much, what is the GVA contribution to the fishery sector, 1.24%, and GVA to agriculture sector 7.28%. That means fisheries is playing a major role in economic development of the country. You can see here, fisher folk population also we have conducted the census and livestock census in Andaman and the Lakshadweep waters. FSI was entrusted to carry out the census in Andaman and Lakshadweep waters. We have assessed it. This is the number of fishermen, family members engaged in. These are the full-time, part-time, occasional engaged in fishing activities. Now, India's position in marine fish production, 4th after China, Indonesia, and Peru. And 2nd in inland fisheries production, aquaculture, whatever it may be. In the world, India stands 2nd in the world. This is State of World Fisheries and Aquaculture 2020 FAO. This is the data which I collected from the FAO. You can see these are the major landing center 7, minor minor fishing harbors, major fishing harbors 7, 83, fishing villages 3477. You can see this one. This is the headquarters of Fisheries Survey of India and Mumbai. One branch office is also there in the first floor. This is Marmagaon base of Fisheries Survey of India. This is Cochin base of Fisheries Survey of India. This is Chennai base of Fisheries Survey of India. This is Visakhapatnam base of Fisheries. This is Andaman Nicobar, Port Blair base, wherein I am holding this charge. Now the present fleet of FSI, survey fleet. You can see here now 11 survey fleet is available. All are mostly acquired from, except one vessel, I think. Remaining all from Holland, Denmark, Japan, China, like that we have acquired. 2005 was a new edition, two new editions, two new technologies. These are the vessels. Matsyavrishti. After getting the vessels, we are giving the name, title and all. We are naming these ships. Matsya Nirikshan, Yellowfin, Sagarika, Varshini, Lavanika, Matsya Drushti, Samudrika, Matsya Darshini, Shikari, Blue Marlin, which is in Andaman now. Now, due to some technical problem, it could not be deployed from past 3 years. Then I've been sent here. 90% of the work is over. Probably next month I am going to, if not the DG shipping, it depends upon the DGP shipping certificate. If that goes, I will invite all of you, sir, and we'll go for a one-day cruise also. I will arrange one-day cruise for all of us. Now, this is the Indian EEZ. Have you heard about Indian EEZ? In the year 1976, India has proclaimed this Indian EEZ area 2.02 million square kilometers. The area from the shore baseline up to edge of the EEZ is 200 nautical miles. Within that area, we have to conduct fishing work. Andaman EEZ, you can see. Sorry. See, this is the one method. Demersal trawling. A bag-shaped net towed by a trawler, drags on the bottom, which is a destructive fishing method. Since ancient times, this is being used. This in Andaman, the fishermen wanted to implement. Some committee constituted, they were not given permission. So they are abusing, that is different. But because this is a coral bed, rocky bottom, so we have to first bottom topography we have to see. If topography is plain or sandy bottom, muddy bottom, we can operate. If it is a coral or rocky bottom, net will get damaged. So this is a destructive. However, this is only basis for our fishermen to harvest the fishery resources. This is midwater trawling. Name itself pelagic trawling, midwater. Here net won't touch the bottom. It is eco-friendly fishing method. First, we will sight the shoal through sonar, echo sounder. After sighting the shoal, suppose we have sighted the shoal at 230 meter depth. Then immediately net will be taken with the help of water boats. Net will be taken to that depth and will be dragged. It won't touch anything. But this is this catches only single species fish, pelagic dwelling animals, mackerel, sardine, pomfrets, carangids, ribbon fishes, some commercially important varieties available, seal fishes, kingfish, what we call. This is multi-filament and monofilament tuna longline. Now, almost to reach to the level of stagnation in the coastal waters, fishing pressure is more. Still, now earlier area is same. Boats increased. Earlier 10,000 boats were there. Now more than 2 lakh boats are there. So same area we have to share. Automatically sharing of resources are getting reduced. So for that reason, beyond 500 nautical miles, beyond the 500 meter depth zone, only oceanic species like tuna and allied resources, billfishes and swordfishes, sharks are available. For which this technology was introduced by our organization. This is with the bait fish we operate this. This is called a basket. This one, what is this one? Right. From here to here, how many branch lines are there? 5. Each branch line length is 20 meters. Means this branch line also 20 meters. The distance between 2 branch lines is 50 meters. To avoid entanglement of these two branch lines. The thermocline depth is more important for tuna fishing. After sighting the thermocline depth, we have to temperature tolerance is 28 to 31 degrees for tuna resources available. After seeing the thermocline depth, we send to the up to thermocline depth. We will send to the this gear fishing gear to that level. Then we operate. The temperature is not there. Water is turbid. Definitely, fish will not be there. So, based on the temperature, based on the thermocline depth, we will operate this. This is a new technology. We will see that this is the technology we have in present now. This is perceiving. This is also eco-friendly, but over exploitation is taking place. This is banned. Now in Kerala and other parts, Bombay, Maharashtra, they have given green seals. Earlier, some other material is now disco material, something they are using. So they are catching entire set of shoal. Fish move in schools or shoals, no? Groups. Entire. After sighting the shoal, in a small boat will be there here. That boat, this shoal will be sighted with the echo sound sonar. After sighting the shoal, the small boat will take the net and encircle this thing. It forms like a purse. That's why purse seen. Whatever is there, entire thing will be harvested. Then slowly with the hydraulic system, they will pull it to the deck. Next. This is eco-friendly squid jigging. This is also technology introduced. Squids are highly released and economic important, and it is exported to Hong Kong, Japan, Thailand. This animal is having the tendency to attract towards the light. Photoreceptors will be there. On the deck, you can see the lights. When all these animals they will attract to the lights. When they come close to the ship, they are unable to breathe. By the time when you put the surf in the water, you get the foam. Like that, the foam will be formed. That means animals have surrounded your vessel. Immediately, this type of jigs will be sent to inside and rolled in. So all will be gathered on the with this hydraulic pull, and they'll pull it, and all will be collected in this deck. This is normal fishing method, bottom set till net. Just they'll lower it, and tomorrow morning they will leave it, and morning they will harvest it. Next. This is trap fishing. Now coral area, perch resources are more, so coral should not get disturbed. Simply take the trap, put the bait, and lower it in the evening. Morning you can take out the trap. It is also eco-friendly. Bottom set also eco-friendly. It is like long lining technology. These are some of the important resources. Anybody, zoology students are there here? Any zoology student? Zoology, botany. I think you might have studied, no? Do you know the scientific names of these fishes? This is white pomfret. Sorry. This is white pomfret. This is Chinese pomfret. This is black pomfret. These two are same family. This is separate family. So this is seal fishes. What you call Indo-Pacific kingfishers. Mackerel, sardine, cobia. Baki Center Kannam, Semaphora is experimenting with the sea ranching technology to increase the resources. Catfish, Bombay duck. This is the only fish having trilobed caudal fin. Harpodon nehrius, which is available in the half Bombay coast. Only that's why this is called Bombay duck. Duck mouth is like a duck. There are some of the resources: lobsters, shrimps, crabs, octopus. These are the oceanic resources. There are 9 types of oceanic tunas are available, of which main targeted species yellowfin tuna. Tuna salvacates, big eye tuna, Tuna obesus, long tail tuna, Tuna stronghold, Euthynis saphenus, little tuna. This is Oxys tajard, frigate tuna. This is skipjack tuna, Caxwanus pelamis. This is Oxys rochi, bullet tuna. These are the oceanic sharks. You can see different shark. The caudal fin is more than the body size. Alopius pelagicus, pelagic thresher. These are the deep sea shrimps. Identification takes time. I don't want to go deep into the subject. These are the two lobsters. First time Andaman waters we have identified. From Vizag, earlier 121 trawlers are there. All trawlers ventured into Andaman waters. They have harvested entire thing, overfished, gone. Nothing is there. Now it might have been revived, rejuvenated, but trawling is banned. That's why we are not doing. This is the first time in Andaman waters. That is Leniperus somniosus. This is the peerless seven. These are the oceanic. Now myctofish more available in the waters beyond 100 meters. People are concentrating towards how to harvest and how to make the value addition. The people are all scientists are trying to do that. The oceanic squids also available. Now major achievements. We are pioneering fish stock assessment, CMFRI and FSI. We carry out the assessment of each stock. How much stock is there? How much can be harvested? How much we should have, such by maintaining sustainability. Sustainability is nothing but we have to have. We are having these resources. We are eating. We should have these resources for future generations. So like that, we are involved in. That's why we are evaluating the potential. We are assessing. This is location of fishing grounds, as I told you already. Then perch resources, 42 species belong to 21 genera. Through our surveys we have conducted Andaman waters. Then we are involved in policy making decisions and code of conduct responsible fisheries, which is the FAO voluntary code. It says do's and don'ts. It talks about aquaculture. It talks about marine fisheries. It talks about research, what to do and what not to do. India is a member country of FAO. We have to follow the guidelines given by the FAO. We have to popularize the code for conducting responsible fishing practices. Next, comprehensive fishing policy. Now uniform ban on fishing. Now continuously we are fishing. At least some gap should be there. Earlier 41 days they started implementing the banning. Now all state government fisheries and state fishermen associations have agreed. Now 65 days in both the coasts of India it is being implemented. So based on the scientific inputs given by FSI and CMFRI. Most of the fishes we found that during monsoon season it breeds, it gives birth to young ones. We have to allow them to breed and give birth to young ones. We have to allow them to grow to the harvestable size. Sorry. Fishing is conversion. We are involved in conversion of fishing into monofilament tuna. Fishing pressure is more in depth of 100 meters, below 100. So we are trying to encourage the fishermen to diversify their fishing activities towards long line, for which 15 lakhs subsidies is also being provided by NFD, National Fisheries Development Board, Hyderabad. This is a tuna tagging program in Lakshadweep and Andaman waters we have conducted. We got the pop-up tags from Australia. We have carried out this experimental tuna tagging program in association with IOTC has sponsored the program, and we have come to Andaman. We live tunas we have caught, we tagged it and we released it back to the sea, and we could trace out the migrations to understand the migration, where exactly the stock is available, where exactly these tunas are migrating, what are the places there, their water samples we are collecting, and we have experimented in both Lakshadweep and Andaman waters. These are some institutional linkages. Have you heard about fishes also can be caught by through remote sensing? Suna satellite remote sensing से बोल सकते हैं आप? Can you say? What do you know about? We have undertaken projects with the Space Application Center and INCOIS Hyderabad. Around 6 projects we have undertaken to identify the potential fishing zones. We get the imageries directly to the ship from the satellite. They will be sending the imageries of chlorophyll and sea surface temperature. Why chlorophyll and sea surface temperature? As I already told you, the sea surface temperature for this tuna fishery, 28 to 31 degrees is optimal temperature required. So when the temperature is there, chlorophyll is nothing but plant material. So photosynthesis takes place, it multiplies, it grows. So these two imageries, based on these two imageries, wherever food is there, the animals will be there. Wherever favorable temperature is there, their animals will be there. So likewise, we have identified the fishing zones, and we are giving the message to the fishermen. We are the member of the IOTC, which is the FAO body, Indian Ocean Tuna Commission. Tuna fishing nations are the members of this organization. We have to submit, or they will provide the technical support, scientific support to us, and we all participated and gone to many countries, our scientists, and participating in IOTC Commission meetings, working groups, and we have to submit the data requirements to Indian Ocean Tuna Commission to understand whether overfishing takes place or how it is taking place. Earlier, FSI was given the responsibility of 5 minutes. I'll finish. Responsibility of earlier Government of India charting of fishing vessels, leasing of fishing vessels, joint venture. These three activities are there. The data should be submitted by the private entrepreneurs to us. Afterwards, LOP system of ASCOM, letter of permission. Foreign ships with Indian flag they can fly, but they have to give the data sets to us, and the Government of India will see that. But in between, some kind of mismanagement taking place. They are transiting outside sea. Motherboard will come, mothership will come. They will show less quantity. Then that was abolished in the year 2015. Later now, new system is going to come. That will be in the draft form. That will be done, because we don't have tuna longliners. The other countries having tuna longliners to give them permission to fishing in high seas beyond even EEZ also. We have Bay of Bengal large marine system. You can see 8 countries under Bay of Bengal region. Director General FSA was nominated to see the Bay of Bengal program action designed to improve the millions of lives of coastal populations. What are their requirement? What is required to be given? What are the subsidies to be given? Any huts, any houses are to be given. All things will be discussed under our bubble project. We go and directly stakeholders consultations. We are organizing and we are doing. This is some of we train the fisheries officers of the state governments, and in turn they train the fishermen. That is moving towards such a trainers training program we are organizing. And marine fisheries census, already I told you, we have conducted 2005, 2010 and 2016. This is a revalidation potential. I told you, revalidation potential 91, 2000, 2011, 2018. This is the FSI is recognized by Mumbai University, or Goa University, Cochin University, Andhra University, and Madras University. Action. Whatever data we have collected, we disseminate the information through regional workshops, open houses, marine exhibitions, and open houses. You see, all students will come and see the laboratories, the equipment, the gates, everything. They will come and witness it. We participate in fish festivals and World Fisheries Day. Ministers and all visit in Delhi. We go and participate actively in the events. Capacity building. We impart training to their skippers, to those who want to become skippers, captain of the fishing vessel, second officers, engineers. We impart training. After acquiring sea service, they will become captains of the vessels. They have to get the sea service from fisheries. This is at fishermen also we are training. Some fishermen training, sea safety measures, firefighting. Then this gear, then these are the publications: fishery charts, Mina News, resources, information series. I told you which is published in all the regional languages. These are some of the publications. You can see Goa, Karnataka, Kerala, Coast, Tamil Nadu, Puducherry, AP, Odisha, and West Bengal. Various states, whatever the data we are collecting, all will be published in the form of bulletins, charts, atlases. This is here you can see Andaman Atlas. Potential estimates, since beginning we are doing it. These are the remote sensing forecasting. If you want to know what are the data, we have collected, we'll be able to provide the documents. Other publications. These are the giant vessel. I told you already. Giant vessel chartered vessels reports. We have one more edition, marine engineering division. Small fishing boats, other sister vessel boats. We have the dry docking facility at Kochi. MED, Marine Engineering Division. There, other sister organization boats will be dried docked. Minor repair works will be attended. And life raft station. We have a life raft station also. This is an additional revenue generated instrument we have got acquired from other department. We are taking from the slipway, other Coast Guard vessels. You can see. We have dredge here. And these are the northwest coast, southwest coast. Lot of achievements, lot of data, whatever new research identified, we have brought into in the form of this thing. Since we don't have time, I don't want to read and tell you. Andaman Nicobar, what are the things we have located? Lakshadweep. Other contribution, we have introduced various technologies. Introduction of monofilament in the year 1980. Introduction of, that is multifilament, this is monofilament. This is porcine, bottom side particle learning, tuna long lining, squid jigging, pot fishing, octopus for catching cuttlefish and octopus. This pot fishing is also experimented. These are the traps. New one more technology: swordfish fishing with light sticks. Lights, when you break it, lights will go inside you when it goes. Swordfish attracts towards light. They think that is a prey. They come and close and they catch it and they will be trapped.
Is it not bad?
No, it's not a bio this thing, not dangerous chemical. So we disseminate the information through Doordarshan, All India Radio, fleet management plan. Now what I told you, the fleet is increased, committee constituted. They are trying to optimize the fleet so that to avoid the disputes among the states, neighboring states. Suppose Bengal people are coming to Orissa people are going to West Bengal. Something like that is happening. Tamil Nadu goes to Karnataka. Things are happening to avoid conflicts. The Ministry of Fisheries is optimizing the survey. This is now potential yield. I am telling you. Now we have the resources of 5.31 million tons. Demersal, bottom dwelling, 2.3, and pelagic resources we have the resources 2.63. Lakshadweep we have 1.44. Andaman waters 3.7, 0.37. Oceanic, entire oceanic waters we have more. You can see that we have the potential of oceanic beyond 500 meter depth zone. We have a lot of potential. We have to venture into deep waters. Futuristic vision. Having completed 75 years, we are going to monitor the state to understand the status of fishery resources. To give the information, some geo report data. We have very good data bank. The fishermen will come and collect the data also. Then this is a proposed research projects. Pursuing Lakshadweep we are proposing. Then Lakshadweep tuna live bait because to catch the skipjack tuna live bait will be collected from the wild. So that also we are going to take up. And mesopelagic resources, it's mythophytes, that also we are going to undertake. As rightly said, I think plastic pollution also we are going to take up. And we have undertaken recently we have undertaken one project called mammalian survey. The US has banned our products to get import our products. Until unless you conduct the mammalian survey, how much stock is there, how many mammals are there. If you are not conducted, see patients, whatever. We have conducted and we have submitted the report last December. Then we have to submit to US. Then only they will take our products. Because mammalians are endangered species. We are catching all dolphins and everything. So people are eating also. So they don't want that product. So that's why we have been asked to carry out the mammalian survey. That we are going to continue in coming days. See, marine mammals and turtle study in addition to regular service. We are proposing these are the GS mapping also we are proposing. Studies on marine litter with reference to fish. These are the areas we are proposing to take up in coming days. Thank you very much. Since time is very short, I just cut short my talk. Hope that my talk will not give you boring. Thank you so much. Thank you. Thank you very much.
Small.
Yes, sir.
See, there is a conflict between traditional fishermen fishing group using small boats and dinghies and fishermen using trawlers. This conflict is already there. Yes. In order to it, this porcine fishing is posing detrimental to the fisheries resources and also the livelihood of traditional fishing persons. So how are we going to deal with this?
Sir, MFRA is there, sir. Marine Fishing Regulation Act. Every state is having marine fishing regulation, its own regulation. Acts, regulations, all are in force. It is there, but it's not properly being implemented. Suppose now uniform ban they are implementing. Certain fishing boats illegally they are going. and small boats are allowed to venture. That should not be there. And these boats permits also should be looked after by director of fisheries. Every state. They are the main agency. They have to follow the guidelines given by the central government. And even state governments also, they have their own setup. But illegal activities are going on. That we cannot. Somebody has to monitor, sir. Now your fisheries department strictly monitoring the things. That strict implementation of this thing is there, the policies, everything will be ordered. The companies always there, sir. Everywhere. Greediness. Suppose an Andhra fisherman is venturing into directly Odisha. They're catching that fish and bringing back and they're selling it. It's wrong, sir. The limited area, 12 nautical miles is given for state fisheries, which comes under the state jurisdiction. Beyond 12 nautical miles comes under the central jurisdiction. We have nothing to do with that. Anything else? Thank you. Thank you very much. Thank you. One small 5 minutes video, just see and enjoy it. Please, sir. I request my scientist Rahul. You will enjoy. Tuna tagging, 2 minutes, and trawling, 5 minutes. Just see and enjoy. So that you will be relaxed with a good mind and all you will go. Relaxed mind.
This is a tagging. How we are tagging the tunas on board the vessel. This is the long line of Master Rusti, which is attached to the Mumbai base of fisheries service. The scientists is deputed to tag this type of tunas and they are taking on board the vessel right now.
This is the tuna. You can explain.
This is the normal practice which is conducted on board the vessel. This is the one of the monofilament which is introduced in year 2005. One in East Coast, one in West Coast. This is the West Coast vessel with norm of the Master Rusti. This is the yellow fin tuna which is caught. The scientist is inserting the left tag. This is the tag. Pop-up tag. This is our scientist, Kiran Manish and Jadwal. So in that condition we are using that. And now another video is regarding the what we are doing in our trawling part. This is conducted in the Visakhapatnam base of fisheries of India. One small video is there. You can enjoy and you can come to know the what actually we are doing at the trawling grounds and what our scientists doing on board the vessels and how we are disseminating the information.
One year prior to the Indian independence, on 26 August 1946, the then government formed the Deep Sea Fishing Station, the present Fishery Survey of India, for the augmentation of food production and development of deep sea fishing in India. The Visakhapatnam zonal base was established in the year 1958 as offshore fishing station. It was subsequently renamed as Exploratory Fisheries Project during 1974 and later as Fishery Survey of India in 1983. Matsishikari and Matsidarshini are two survey vessels that are stationed at Visakhapatnam. They are engaged in demersal and pelagic fishery resources survey. The area allocated to Visakhapatnam base for the survey activities extends from 16 degrees north latitude, that is Machilipatnam in Andhra Pradesh, to 21 degrees north latitude, that is Sandheads in West Bengal. The survey vessel MFV Matsishikari, a bottom trawler, was built in Holland in 1978 and has completed 42 years of service to the Government of India. As it is now ready for monthly survey activities, it is leaving the fishing harbour and moving towards the fishing ground as per the designated survey program of Visakhapatnam base of Fisheries Survey of India. The port city of Visakhapatnam, also known as the City of Destiny, is a growth engine for Andhra Pradesh economy. Very long ago, it was just a fishing village on the east coast. Now, it is the largest city in Andhra Pradesh, apart from being an industrial hub. Visakhapatnam is a natural harbour, and the fishing harbour accommodates 750 mechanized, motorized, artisanal vessels that indulge in one-day and multi-day fishing. The control of the ship is from the wheelhouse. For maneuvering the ship, the rudder is essential. The skipper of the vessel establishes contact over radio telephone. It is the only medium of communicating with the shore when the vessel is in deeper waters.
रासायनिक शिकारी रासायनिक reading of 5. Note down present position. Vessel position 17 degree 41 minute north, 8083 degree 20 minute east.
Various sophisticated equipment, which are mandatory requirements at sea, are available on board the vessel. Radar shows the surrounding objects of the vessel and also the distance from the ship. Global Positioning System (GPS) shows the position, latitude and longitude of the vessel. The echo sounder is used for depth measurement and also for locating fish shapes. Barometer is a one which indicates the atmospheric pressure by which the weather condition can be assessed. The automatic identification system identifies the surrounding vessels in the range of 48 nm. Charting is an important concept in vessel navigation that identifies the position of the vessels with the coordinates. The skipper ensures that the ground condition for trawling is fine to avoid damage to fishing gear. Thereafter, the skipper will discuss the ground position, sea state, and type of net to be operated with the cruise leader.
Depth is now 33, so we are reaching to that we shoot the net in 36 meter. We are reaching within 10 to 15 minutes. After 10 to 15 minutes, we will start the shooting. Wind northeast and current southwest. session. We're reaching fishing ground 10 to 15 minutes.
The vessel reaches the fishing ground and prepares for shooting the net. The trawl nets, or bottom trawl, are made up of synthetic twines or ribbons. There are different parts of nets like coat belly, wing, head rope, foot rope that are made up of high density polyethylene webbings or synthetic nylon twines. The coating of the net needs to be secured for collection of fishes. As the vessel moves, the 34 fish trawl is lowered to the water from the net jump. The wire rope needs to be released depending on the depth of the fishing operation. It is normally released in the ratio 1:3, fishing depth in meter to wire rope length. The buoys or floats that attach the head rope of the net to keep the net afloat. Once the net is lowered to the desired depth, the opening of the net needs to be maintained with the help of two otter boats at both sides, weighing 1 ton each. The oval-shaped otter boats, port and starboard, are lowered to the sea with the help of a split winch. At this point, the dragging of the net begins. While dragging the net, the speed of the vessel is maintained at 3 to 4 knots. While dragging the net, the skipper keeps a continuous watch on the ecosounder to observe the shoals and accordingly adjusts the position of the net. It is important to maintain a close watch on the surrounding ships or the environment while the vessel drags the net. After the declaration of the exclusive economic zone, India has a sovereign right to explore, utilize, manage and conserve the marine resources in 2.02 billion square kilometers area. In 1983, the organization was renamed as Fisheries Survey of India, with headquarters in 7 bases, one in Porbandar, Mumbai, Gurgaon, Kochi to the west coast of India.
Now, Bobby.
Into the individual group is taken. Then some targeted species are subjected to detailed biological observations like length frequency, length weight studies, maturity and spawning, food and feeding patterns. Also the parasitic infestation to get and preserve without getting spoiled. Fisheries post-harvest technology and make the maintenance of the vessels.
Okay. Museum library.
With more than 400 records at present.
As promised by Dr. Vinod here, kept the audience very captivated. We enjoyed the presentation made by the lecturer, experienced lecturer, more than the scientist. So thank you very much, Doctor, for your wonderful presentation on the fisheries resources. And there are a lot of reports saying that the Andaman water has a lot of fishes which are dying out of age. So your presence will guide some more proper technical explanation. Thank you very much.
He was asking. No, you give this. Please come. Please come. We are in the all friends. You want your friends.
Good evening, all. Again, I'm thanking both the chairpersons of today's session and the speakers of today's session for it lively, though it is a Sunday. Still the call is full. I'm thanking all the participants. And tomorrow be here as usual 9:50. Morning session will be having live telecast of a grand well victory function which will be held from Delhi. Afternoon we will be having our own well victory session. Our director will teach the PORTBLAIR. Our Honorable Chief Guest, Vice Chancellor will be joining through online. The remaining guest of honor will be joining here. So thank you, on us. 10 o'clock, morning 10 o'clock.
சாப்பாடு